We were not in school Monday. All right, guys, you need your review sheets out. Review sheets out. So, yes. So what I'm planning on doing today is I'm going to go through half the review sheet today. We'll go through the other half tomorrow just to make sure we hit everything. That means your test is Friday. Your test is Friday. And again, I would make sure to go back over these outside of just the time we do in here, because I will give you Friday. Well, obviously, if you have Friday to take the test, and that is it. So we're not going to do 2 days for it. There are 20 questions on the test. Okay? So you'll have the 45, or I think it's 45, 50 minutes to factor 20 problems. I think that's more than doable for those there. Because if I remember the breakdown, 4 are cubics, sum and difference of perfect cubes, 5 are sum or difference of perfect squares, 3 are kind of like number 1, where we just factor out a greatest common factor and you're done. And the last 8 are our 2 sets of parentheses with 3 spaces. Now, the first one I want to look at is number 1. 6a cubed b squared minus 36ab squared plus 71a squared b squared. And again, the first thing on any of the problems, especially on the test, is look for a greatest common factor first. ab squared. Because all 3 terms do have an a and a b squared. Well, b squared is in common with all 3, so that one's kind of easy to see. We do have a cubed, a, and a squared, so the most we can take out of all 3 is just a single a. Now, if we factor ab squared out of the first term, we still have 6. A cubed becomes a squared, and the b squared factors out completely. Minus 36. A factors out completely here, and b squared, so we're just left with minus 36 plus 71. When we factor an a out of a squared, we just have a, and the b squared factors out completely. Now, at this point here, we can rewrite it. 6a squared plus 71a minus 36. And all we're doing here is just rewriting it in standard form, because standard form is our variable with the biggest power goes first, and then in decreasing order. And at this point here, we're done, mainly because here there's a good chance we can use the factors of 6 and 36 to get 71, but it actually doesn't work out. So this here is the final answer. Now, if we wanted to check this here, we could use our method of b squared minus 4ac. 71 squared minus 4 times 6 times negative 36. Squared minus 4 times 6 times. And because we got a decimal, it tells us it's not factorable. The only way it would be factorable is if we had just gotten 76 with no decimal. It's kind of a way to check and make sure it is factorable. So this is just the square root of b squared minus 4ac. Now, there's not going to be one on the test that does not have a greatest common factor or factor in any way, shape, or form, where you do nothing. So they're all factorable, either be it factor out like we did here, the greatest common factor out, and then we're done, or 2 sets of parentheses. There's not going to be one like number 10 where we can't do anything. I want to go on and look at number 2 next. 36x squared minus 49b squared. If we're given 2 terms, it's either going to be sum or difference of perfect cubes, or sum or difference of perfect cubes, or difference of perfect squares. This one kind of tells us exactly what it is because of the x squared. It's going to be a difference of perfect squares. The difference of perfect squares, we know we'll have two sets of parentheses with three spaces, and the signs are going to be opposite. Now it's figuring out what times itself is 36x squared. 6x, so the first spots would be 6x and 6x. Now we can write it as 6x inside parentheses squared minus, well, what times itself is 49b squared? 7b, and we could write it as 7b squared. So we get 6x plus 7b times 6x minus 7b. Now, if we do notice that it is a difference of perfect squares and you're having trouble figuring out what times itself is the given number, we can take the square root of it. Because the square root of 36 is 6, square root of 49 is 7. The calculator will tell us what those are. We just can't plug the variables in because, again, the calculator has to have a value for said variable. Question on number 2. I know I went a little quick through that, but questions on this? And again, this is just following our a squared minus b squared is equal to a plus b times a minus b. In our case here, a is 6x, b is 7b, and we're just plugging into the given formula. Does that make sense? We ready to look at number 2? Yeah. Whoever numbered this problem did a poor job, or numbered this worksheet did a poor job. Yeah. It's okay, you can agree with that. So when we look at this one here, 4x squared plus 12x plus 9. Again, always look for a greatest common factor between the three terms. Well, 4x squared and 12x do have a greatest common factor of 4, but the 9 does not. So 4, 12, and 9, there's not a greatest common factor. X squared x, constant term, there's not a variable, so there is no greatest common factor. Two sets of parentheses with three spaces. So we find the signs. If the third term is positive, the signs are the same and match the sign of the middle term, which would be plus and plus. 4x squared, well, we will have x and x, and yes, because with 4, we do have 1 and 4, or 2 and 2. And we can start off with 2 and 2, because we just need to pick one of those sets of factors. Factors of 9 are 1 and 9, or 3 and 3. And we can start off with 3 and 3. Now, we didn't check the last one, but we can check this one here. 2x times 3 is 6x. 3 times 2x is positive 6x. And 6x plus 6x is 12x. Now, we can't technically check or plug in 6x plus 6x in the calculator, but we can plug 6 plus 6 in the calculator, which would give us positive 12. 6 and 6, sometimes with especially our negatives where we have negative x plus 12, or some of those might be a little, if you want to make sure you can plug those in, just drop the variables and keep the number with the signs. But 6x is 12x, which is the middle term we want. So this here is the final answer. And yes, there is another way we could write it as 2x plus 3 squared. You don't have to have both of those, you just need one of them. So if you left it as 2x plus 3 times 2x plus 3, that is correct. That is the correct answer. If you wrote it as 2x plus 3 in parentheses squared, that works too. Questions on this here? Are we good with this here so far? Yes? Okay. Yes. I need that, but we are going over the review. So you can put that on my desk. All right. We good with problems 1, 2, 2, and I think, yeah, 1, 2, and 2. Yes? We're going to skip 3 and 4 for now. I want to look at 5. Because 3 and 4, for the most part, are exactly like the second number 2, two sets of parentheses with 3 spaces. So first number 2 is a difference of perfect squares. Yeah, and I didn't check the first one, our difference of perfect squares, mainly because it is a set form. We have it because it is following a set formula. We find the square roots, plug them in with plus, plug them in with minus, and we move on. Now you can check those if you want, because there's nothing wrong with it. You will find that the middle term is 0, and we can move on from there. Now the reason I want to look at number 5 instead of number 4 is if we look at this here, 8x squared plus 6x minus 27, well, there is no greatest common factor, variable-wise, because one of the terms does not have a variable. So if we look at 8, 6, and 27, 2 does go into 8 and 6, but unfortunately doesn't go into 27. 3 does go into 27 and 6, but not 8. So it doesn't go into all 3. So there isn't a greatest common factor. So I have 2 sets of parentheses with 3 spaces. The next thing we can do is find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Third term, our signs are opposite. So here, since the third term is negative, our signs are opposite. One's going to be positive, one's going to be negative. Factors of the first and third term. Factors of 8x squared, well, we know we'll have x and x. They go in the first because it came first. It's part of the first term. Which leaves us with the factors of 8. 1 and 8, 2 and 4 are the only sets of factors for 8. Factors of 27. 1 and 27, 3 and 9. So for x, we need to pick either 1 and 8 or 2 and 4. 1 and 8. Factors of 9. I'm going to go 3 and 9. Now at this point here, 8x times negative 9 is negative 72x. 3 times x would be plus 3x, giving us negative 69x. So that's way off. We can flip 3 and 9. 8 times negative 3x is negative 24x. 9 times x is 9x, giving us negative 15x. So that's not quite it. Now we could switch to 1 and 27, but most likely that's not going to work because we're either going to multiply 27 by 9 or combine 9 and 27. What might work a little better is 2 and 4. We might need to switch it, but we can start here. 2x times negative 3 is negative 6x. 9 times 4x is plus 36x. So let's switch the three and 9. 2x times 9 is negative 18x. Doesn't look promising so far, but 3 times 4x is plus 12x, giving us negative 6x. Flip the signs. We got the correct number, but wrong sign. Anytime we get that, we're going to flip the signs. If you get the correct number, but wrong signs, just change the signs, because now we'll have 2x times 9 is positive 18x. Negative 3 times 4x is negative 12x, giving us the positive 6x we want. And that's it. Some of the times, whenever we have a smaller middle term, we try to pick factors that are closer together. If it's a bigger middle term, we might need factors that are a little bit farther apart, so we get a bigger number. Questions on this here? We ready for the next one? Next one that I have down that I want to look at is number 6, 64x squared minus 1. Two terms. Look for greatest common factor first. Even if we do know it's a difference of perfect squares or some are difference of perfect cubes, find greatest common factor first. Here, there's not one. One of the giveaways is the fact that one of the terms is 1. So we're kind of stuck there. But since we still have this x squared term, it is going to be a difference of perfect squares. And with difference of perfect squares, our signs are opposite. One's positive, one is negative. Now, the nice thing with this here, what times itself is 1? 1. That's part of the reason why I did it first, because, well, 1 squared is indeed 1. What times itself is 64x squared? 8x. So we'll have 8x and 8x. I will say this, especially on the test, since, again, for those that just are a little bit late, I am giving you Friday to do this, and only Friday. There won't be an extension on it. Now, even if you do get stuck on one of them, difference of perfect squares, at least give me the signs, because there are points for getting the correct signs. Because even the next one, we are going to look at number 7. We know for sum or difference of perfect cubes, the signs follow a pattern. Same, opposite, always end on a positive note. So for 7, the sign should be plus, minus, plus. There's at least 1 point. Even if you don't get the rest, you can at least get the signs. Because if we look at number 7, greatest common factor between a cubed and 1, well, there's not one. Because one of them's 1, the other is just a variable. Now, we can tell it's a sum or difference of perfect cubes, mainly because of the variable is to the third power. So it's going to be a sum or difference of perfect cubes. Now, a cubed is just a. The cubed root of 1 is 1. Incidentally enough, 1 is the only positive number whose cubed root and square root are the exact same. Now, since this is a sum or difference of perfect cubes, we have our parentheses with 3 spaces and the parentheses with 5. Our signs, same, opposite, always end on a positive note. Since we're talking about plus in the middle, same would be plus, opposite would be minus, and the last one would be plus. A is our first term because it came, a cubed came first. So in the parentheses, our first spot would be a. In the bigger, we'd have a squared, a to the first, and then no a term. Our second spot is going to be with our 1. So we have 1. With our a squared, we don't put a 1. In the middle, we would have our 1 to the first power, and then in our last spot, we would have 1 squared. Now, we will need to simplify our quadratic, the bigger part of this here. A squared is, well, a squared minus 1 times a is a plus our 1 squared, which is 1. And it didn't really seem like it simplified much, and that's just dealing with the properties of our a being squared is just a squared, and the fact that 1 squared is 1, it didn't really change much. Questions on this here? We ready for the next one? The next one I want to look at is number 8, 8x squared minus 72. Again, the first thing we should always be looking for is the greatest common factor. It is 8. 8 will go into both 8x squared and 72. Because if we factor 8 out of 8x squared, we're left with x squared. If we factor 8 out of 72, we get 9. I will emphasize this here. I will also emphasize it on any of the problems tomorrow. If there's a greatest common factor, you need it as part of your answer. Because when we completely factor, greatest common factor is part of that final answer. So here the 8 is a part of the answer. Now we do need to factor x squared minus 9. We have two terms, so it's either a difference of perfect squares or difference of perfect cubes or sum of perfect cubes. This is going to be squared because x squared, yes. So our signs are plus and minus. What times itself is x squared? And x. What times itself is 9? 3 and 3. And that's it. Questions on this here? If it had been x squared plus 9, 8 times x squared plus 9, we're done. There's nothing else we can do to that there. If it had been minus 10, 10's not a perfect square. We're done. Any other questions on anything we've done so far? We're going to look at number 11. 49x to the fourth plus 343x cubed plus 7x squared. Is there a greatest common factor? 7. Because 49 and 7 we can see is 7. Yes. And if we divide 343 by 7, it will simplify down. Now this time we do have a variable, because x to the fourth, x cubed, x squared, they do all have an x squared term. And the way we know the power is whatever the smallest exponent attached to that variable is. On the first problem we did on the review sheet, a smallest power was 1, so we just took a to the first. Here it's x squared, so we take x squared out. If we factor 7x squared out of 49x to the fourth, 49 divided by 7 is 7. If we take 2 x's away from x to the fourth, we're left with x squared. Plus 343 divided by 7 is, and then we'd have x, because when we take 2 x's away from x cubed, we're left with 49x. That's 1. Anytime it factors out completely, 7x squared over 7x squared, if we factor it out, reduces completely to 1. It will never be 0. Because essentially what we're doing is dividing each term by 7x squared. And whenever you divide something by itself, it is 1. And incidentally, this is as far as it goes. Because there's no way the factors of 7 and 1 are going to get to 49. And we could check it just like we did the first one. Square root of 49 squared minus 4 times 7 times 1 is 48.7134478.4. So that's as far as it goes. If we had just gotten 48, then it would indeed factor, and we could go through the process of factoring it. Questions on number 11? Be ready for the next one. Number 12. (2,193x cubed minus 216). Well, the x cubed gives us a hint at what this one's going to be, either the sum or difference of perfect cubes. The only way it wouldn't is if the other term had an x with it. Because if it had 216x, we can factor the x out. It becomes a difference of perfect squares. Perfect cubes. Now there's not, at least variable-wise, a greatest common factor. there could be one with our numbers. Can we see one? 2 is not there. And we could keep going there. We could also, 2197, 3 second radical, 2197. Yep. So that is a perfect cubed already, yes? And since it's perfect cubed is 13, there's a good chance there is no greatest common factor. So what that's telling us is off to the side, we can say the cubed root of 2197 x cubed. Well, 2197 is 13, and x cubed is x. We also need to take the cubed root of 216. Three second 216 is 6. Questions on this here? So this here, the reason we do the cube roots is just to get the values that we're going to plug into our corresponding spots. Three parentheses 5. Our signs are going to be what? The same, opposite always end on a positive note. Since our original problem started out with subtraction, our first one is going to be minus. Opposite is plus. Always end on a positive note will be plus. $13x came from the first term, so it's going first. We'll have 13x. In the bigger one, our first spot is going to be 13x squared. Then we'll have 13x to the first, and the last one will not have a 13x. Our other term is 6. Won't have anything with our 13x squared. The middle would be 6 to the first, and the last one's going to be 6 squared. Now we do need to simplify our 13x minus 6 is as simplified as it gets. 13x squared, we do need to multiply it by itself. We're squaring it. 13 times 13 is 169. Plus, then we're going to do 13x times 6, or 13 times 6. 78x, and 6 squared is 36. So we could still type some of this in the calculator. 13x squared, we can do 13 squared, which would give us 169. And then we have x squared, because x times x. Yeah, because we're just saying 13x times 13x. 13 times 13 gives us the 169. X times x gives us x squared. 13x times 6, 13 times 6 will give us the 78. We still have our x. And then 6 squared is 36. So we're really saying we're multiplying it by itself. You're welcome. Any other questions on number 12? We good with 12? Let's look at 13. 375a cubed plus 192b cubed. Sum of two cubes, sum of perfect cubes. Now the first thing we can do is go on and take the cubed root. 375, set 3 cubed root. 375 is a decimal. If you take a cubed root of one of the problems, especially this one here, it is a difference of perfect cubes, and we get a decimal, that means there's a good chance that there is a greatest common factor. So if we look at these two here, start with smallest greatest common factor we have and move up. Will 2 go into both 375 and 192? No, it will go into 192, but not 375. Then we can move on to 3. Will 3 go into both? 5. So 3 does work. So we could keep going higher, but that works. And actually, that is as high as it goes. So we need to factor 3 out. And if we divide 3 by 175, we have 125 a cubed, guys. Let's focus in here. And if we divide 192 by 3, we have b cubed. And we took cubed root of 125 a cubed. 125 was 5, and a cubed is a. Cubed root of 64 b cubed is going to be 4b. So since it's a sum of 2 cubes, we have our parentheses with 3, parentheses with 5. Our signs. So the same as what we started with. So plus, opposite would be minus, always ended on a positive note. Our first term is 5a. And since it came first from our 125a cubed, it goes in the first blank. And it's also going to be the leading one and our bigger one. So 5a squared, 5a, no 5a. Let's go purple. So 4b, we go in the other spot. In the middle, we would have 4b to the first. And the last one, we'd have 4b squared. Questions on how we got this set up here? Now we do need to simplify. The 3 is going to be included in our answer. Now we would have 5a plus 4b. 5a squared, 5 squared is 25. A squared minus 5a times 4b. 5 times 4 would be 20. AB plus 4b squared. 4 squared is 16, and b squared is b squared. And that is it. Normally, if the degree of whatever is inside the parentheses drops below 2, the biggest exponent in there is 2, and it goes below it, we're done. That can't be factored any further unless there's just some greatest common factor in common. Sum and difference of perfect cubes, the quadratic part, the bigger part, will never factor any further than that there. That is as simplified as it gets. Questions on these so far? Now, hopefully you're trying to notice this with sum and difference of 2 cubes, there is a set pattern, especially with how the bigger part goes. Squared first, none, none first, squared. And we have our other 2 terms. But to round this off, let's do one more. 729x to the third minus 8. We can look for a greatest common factor between these two. 8's kind of nice because its only factors are 1, 2, 4, and 8. Yes? 729 is not divisible by 2. Most likely not 4 or 8, so there's probably no greatest common factor. Now we can see if we have a perfect cubed, and well, if we do, it is 9. While we're at it, let's take the cube root of 8, which is 2. So off to the side, we can say the cubed root. X cubed is 9x. Cube root of 8 is 2. Now, just for reference, if you do not include the cubed root of 729x cubed and the cubed root of 8 on your worksheet, or on your test, that is fine. I'm not going to count off. We put it there as just a way to reference it so we know which terms we're plugging in where. Now, our signs. Same, opposite always end on a positive note. Since it was started out with minus, same would be minus. Opposite would be plus. Always end on a positive note. Since 9x came from our first term in our starting problem, it goes first. In the bigger, we would have 9x squared. Middle, we'd have 9x to the first. And the last spot, we would not put a 9x term. Now we're going to plug in our second term of 2. So we'd have 2. Middle would have 2 to the first. And the last one, we would have 2 squared. In our simplified form, we'd have 9x minus 2. 9x squared. So really, we're doing 9x times 9x. 9 times 9 is 1, and x times x is x squared. Plus 9x times 2 is 18x. 2 squared would be 4. So the final factored form of this here is 9x squared times 81x squared plus 18x plus 4. Questions on any of these here? Well, we do have time. We can go on and do 15 while we're at it. Two sets of parentheses. The reason we skip greatest common factor is, well, there's not a variable in all three, and the number in front of a squared is 1. Since the third term is negative, our signs are opposite, positive and negative. Factors of a squared are a and a. 6 is 1 and 6, or 2 and 3. 2 and 3. We can check this here. A times negative 3. It's negative 3a. 2 times a is plus 2a, giving us the negative a term we wanted. And that's it. One other thing I will say, especially on the test, if you hit one of them where you get stuck, do not stay on that problem. Move on. And that's a big thing, especially when you're taking the ACT. If you get stuck on a problem, move on. Guess and move on. Because there's a good chance that one of the problems later on you'll be able to do. Now, if you are getting stuck on greatest common factor, do not stress about that, because if it is factorable and has a greatest common factor, it still factors. Yep. And you can do that too. Yes. But we will finish this here tomorrow.